The first step we have to do is we have to check the winding resistances of our 3-phase induction motor, meaning that the winding 1, 2, and 3 must be perfectly balanced with each other. Always keep in mind that checking the winding resistances of our 3-phase induction motor, whether it is new or an old one, is a must. For example, you are about to replace the 3-phase induction motor of this condensing unit and you are not sure about the winding resistance of your 3-phase induction motor. So this is located in a very high place and we need to use a crane. And you are already bring your motor here and found out that your winding resistance are not perfectly balanced or with an open winding, shorted winding, or grounded winding. So this will give you a very big problem. Or for example, you are an installer and you have this project 100 kilometers away and you don't check your induction motor before getting in your stock room or leaving your company. So checking the induction motor's winding is very important. For example, we have a 6 leads induction motor. So what we are going to do is we will check the W1 and W2, which is the first winding or the T1 or the T6 terminal of this terminal block. If for example we get 1 ohm on our first winding W1 and W2, so on our B1 and B2, the second winding or the T2 and the T4, we should get also 1 ohm, and same on the third winding, which is U1 and U2, which is located on T3 and T5, so there must be perfectly balanced with each other. If they are not perfectly balanced with the resistance, at least a minimal difference. So this is an open configuration of a 6 leads induction motor. So we will go on how to check on Y or delta configuration. Now that we have found that we have balanced resistance on our 3 windings, it is about time to check for grounded winding. So what we are going to do is to put our 1 test lead on the ground terminal of our 3-phase induction motor and put our test lead one by one on our W1, B1, and U1. So in testing, if we have grounded winding, so we must get an infinite reading. Kilo ohms or mega ohms is not acceptable, or any value reading. It must be infinite reading only. Now we will move on how to check delta configuration. If you will see, they are now having a connector W1 and B2, P1 and U2, and U1 and W2. To check the winding resistance of delta configuration, we will put our test lead on our W1 and B1. It must give us a reading of 0.67 ohms because the winding resistance of delta configuration is only 67% of an open winding configuration. The second testing will be from B1 and U1. It must give us also of 0.67 ohms and U1 and W1 on the same value reading. For possible grounded winding, same procedure what we have done on our open winding configuration. We will put our test lead on the ground body of our 3-phase induction motor and also on our W1, B1, and U1. So here we are in Y configuration. So same procedure what we have done on our open and delta configuration. We will put our test lead on our W1 and B1. We must get a 2 ohms resistance. Because Y configuration is a series of 2 windings. So if we get a winding resistance of open configuration of 1 ohm, in Y configuration we should get 2 ohms resistance. For possible grounded windings, same procedure on what we have done on our open configuration and delta configuration. We should put our test lead on the ground terminal or the chassis of our 3-phase induction motor, while the other we will put on W1, B1, and U1. We must get only infinite reading. For a 9 leads or 12 leads 3-phase induction motor on how to check their winding resistance on delta or Y configuration, same procedure on what we have done on our 6 leads 3-phase induction motor, but be sure to follow the proper or the right connection stated or shown on their instruction manuals. This is located on our termination box cover. Now that we found out that our windings are good and no possible for grounded, so it's about time to check for the mechanical status of our 3-phase induction motor. No matter how big your 3-phase induction motor, if this is not stuck up, you can rotate it very easily. Check also the status of your bearings and the greasing of your 3-phase induction motor before proceeding on installation or replacing 3-phase induction motor. Now that we have found out that our 3-phase induction motor is in good condition, so we can now proceed on the third procedure. Is your control start-stop, reverse forward, start-stop jog, VFD drives, primary resistor? Those control are the sample of direct online starting. So you must be in Y configuration if you have the higher voltage supply and delta configuration if you have the lower voltage supply. Please always try to follow the instruction on your terminal box cover which configuration you are going to do on your 3-phase induction motor. Please take note that 380 voltage supply is not always a higher voltage choice. It can be sometimes the lower selection voltage depending on the size of your 3-phase induction motor. For a Y delta motor control, be sure to connect your power connection correctly and properly. Please watch my video on how to connect a power connection of a Y delta in a 6 leads 3-phase induction motor. So let us proceed now on our 9 or 12 leads 3-phase induction motor on how to connect their configuration depending on our control circuit and supply voltage. For a low voltage supply direct online starter, you have to use double delta configuration and double Y configuration for a higher voltage supply. It can be also single delta or single Y configuration depending on your voltage supply, which is higher than 230 and 380 volts. So again, please check your termination guide and follow the correct configuration depending on your voltage supply availability. For a soft starting method like Y delta, it can be double Y, then change over to double delta. Remember that your delta configuration must be your basis of your voltage supply. Meaning, if you have 230 volt supply, so you can use double Y for start and double delta for run. For a higher voltage supply than 230 volts, it can be single Y for start and single delta for run depending on your voltage supply availability. For another soft starting method like part winding, it will again depends on your supply voltage. For a low voltage supply, use the first set of delta configuration in starting and the second delta configuration for run together with the first delta configuration. For a high voltage supply, configure your motor in 2 Ys, then your first Y in starting and the second Y for running together with the first Y configuration. So here we are now in our 9 leads 3-phase induction motor. For a low voltage supply, configure your motor in double Y and connect it parallel to the voltage supply, and single Y for a higher voltage supply. For a soft starting method in low voltage, use a part winding motor control. Use your first Y in starting and the second Y for running together with the first Y configuration. Please watch my video on how to perform wiring tutorial of part winding reduced voltage motor starter. Please take note that there is also a 9 leads 3-phase induction motor that are internally connected in delta configuration. And these are the connection for low and high voltage supply.